Hey everyone, welcome to our channel. Today, we're diving into something we all use every day but rarely think about, the internet. Have you ever wondered how it actually works? Well, stick around because we're going to break it down in a way that's easy to understand. The basics of the internet. At its core, the internet is a global network of computers. It allows devices to communicate with each other through a complex system of protocols and technologies. Imagine the internet as a giant web where each intersection point is a device, like your smartphone or computer, and the lines connecting them are the various pathways data travels. When you type a web address into your browser, you're essentially sending a request across this network to access a specific piece of information stored on another computer somewhere in the world. Understanding IP addresses, every device on the internet has a unique IP address, which stands for Internet Protocol Address. Think of it as a postal address for your device. IPv4, the most commonly used type, has a format like this, 19.168.0.1. There's also IPv6, which allows for even more unique addresses, crucial for the expanding number of internet-connected devices. While IPv4 uses 32-bit addresses, allowing for about 4.3 billion unique addresses, IPv6 uses 128-bit addresses, providing a virtually limitless number of addresses. This transition is key to supporting the Internet of Things IoT, where everyday objects are connected to the Internet. The role of ISPs. To connect to the Internet, you need an Internet Service Provider, or ISP. ISPs act as gateways, providing the infrastructure and services needed for you to connect to the internet. They manage the data traffic between your devices and the wider network. When you send a request to visit a website, it first travels from your device to your ISP. The ISP then routes this request through various networks until it reaches the server hosting the website. How data travels. Data on the internet is broken down into small packets. These packets travel across the network, taking the most efficient route available. Along the way, they pass through multiple routers and switches, each directing the packets closer to their destination. This process is known as packet switching. Once all the packets reach their destination, they're reassembled to form the complete data you requested, like a web page or a video. The Domain Name System (DNS). To make the internet user-friendly, we use domain names instead of IP addresses. The Domain Name System, or DNS, is like the internet's phone book. When you enter a web address, the DNS translates it into the corresponding IP address so your request can be routed to the right server. For instance, when you type www.example.com, the DNS server looks up its IP address and directs your request accordingly. This seamless process happens in milliseconds, allowing for a smooth browsing experience. Undersea cables and satellites. To connect continents and facilitate global communication, the internet relies on undersea cables and satellites. These undersea cables, often spanning thousands of miles, carry vast amounts of data between continents. These cables are laid on the ocean floor by specialized ships and are designed to withstand harsh underwater conditions. Satellites, on the other hand, provide connectivity to remote and underserved areas, ensuring that even the most isolated regions can access the internet. Data centers and cloud computing. Central to the internet's operation are data centers. These facilities house thousands of servers that store and manage data. When you access a website or use an online service, the data often comes from these data centers. Cloud computing leverages these data centers to provide scalable and on-demand access to computing resources. Services like Google Drive, Netflix, and Oz all rely on cloud infrastructure to deliver their content and services efficiently. Internet security and encryption. Security is paramount on the internet. To protect data as it travels across the network, encryption is used. Encryption scrambles the data, making it unreadable to anyone except the intended recipient. Websites use HTTPS, which stands for Hypertext Transfer Protocol Secure, to ensure secure communication. This is achieved through SSL, TLS protocols, which establish an encrypted connection between your browser and the website's server. The future of the Internet. The Internet is continually evolving. With advancements like 5G, the Internet of Things, and artificial intelligence, the Internet's capabilities are expanding rapidly. These technologies promise faster speeds, greater connectivity, and smarter services. Smart cities, autonomous vehicles, and advanced healthcare systems are just a few examples of what the future holds. As the Internet continues to grow, it will play an even more integral role in our daily lives. Recap and conclusion. To recap, the Internet is a vast network of interconnected devices facilitated by IP addresses, ISPs, DNS, undersea cables, satellites, and data centers. Data travels in packets secured by encryption, ensuring safe and efficient communication. We hope this journey through the workings of the Internet has been enlightening. The Internet's complexity and ingenuity are truly remarkable, connecting us all in ways once unimaginable. Thanks for watching. Don't forget to like, share, and subscribe for more deep dives into the technologies shaping our world. Until next time, stay connected.